Good day to our respected lecturer Dr. Adida. Today we are from Group 10 would like to present application project of linear algebra in chemistry. My team members are Han K. Eng, Agnes Lee Simney, Chua Cheng Yong and Chi Hui Min. My name is Yamni and my metric number is 272372. Firstly, I will start with short introduction of application of linear algebra in chemistry. Linear algebra has a wide range of application in science and mathematics. In chemistry, the reduced row echelon form is a linear algebra approach that may be used to solve one of science's inevitable tasks like balancing chemical equations. Balancing chemical equation is fundamental when for lab research, the precise ratio of reagents and products are crucial to the success of most chemical reactions. Now we look into why linear algebra is said to be useful in chemistry. Linear algebra is useful in many applications in these sciences. Chemistry uses linear algebra in many aspects of its computation, such it is used to balance a chemical equation in order so that nothing is mysteriously lost or gained. Using linear algebra helps chemists can add exact amount of compounds in order to get the proper result without any waste product. Besides that, by using linear algebra, they can be conservative with the products that they have. Furthermore, it also can be used to find out a chemical's weight per mole in order to find out the substance that it is. Next, how are we able to solve non-homogeneous linear system using Gauss-Jordan elimination method? Primarily, Gauss-Jordan is said to be an algorithm used to solve systems of linear equation and find the inverse of any invertible matrix. It relies upon three elementary row operations one can use on a matrix, which are: first, we have to swap the position of two of the rows, followed by multiplying one of the row by a non-zero scalar, and finally add or subtract the scalar multiple of one row to another row.
Good day everyone, my name is Agnes Lee, matrix note 2697881. So today I will explain the problem 1 that we need to solve in this assignment. So first and foremost, there are three different equations which are A, B, C in order to produce a certain chemical substance. So there are three equations in this problem. So first is suppose that the solution containing A at 2.8 grams combined with the solution containing B at 4.0 grams, combined with the solution containing C at 5.0 grams, which makes the 27.5 grams of the chemical, and this will become the first equation of this problem. So the second equation is if the proportional for ABC has been transformed to 3.0 gram A, 3.0 gram B, and 4.7 gram C in order to produce 26.0 gram of the chemical, and this will become the second equation. Lastly is 2.5 gram of A, 5.5 gram of B, and 4.2 gram of C in order to produce 29.2 gram of chemical. So this equation is want us to find the volume of the solution that containing A, B, C. So to solve the equation, we need to let S, Y, and Z be the corresponding volumes in cubic centimeters of the solution that containing A, B, and C. So therefore, 2.2x will become the mass of A in the first case, 4.0y is the mass of B, and 5.0z is the mass of C. So we add it together, the three mass should be 27.5 grams. Therefore, 2.8x plus 4.0y plus 5.0z equal to 27.5 has become the first equation for this problem. And that's all for me, and I would like to pass to Hui to explain the solution for this problem. Thank you.
Then we apply the same steps to the other cases. Therefore, the linear system will be the combinations of the equations of three cases, which is first 2.8x plus 4y plus 5z equal to 27.5, 3x plus 3y plus 4.7z equal to 26, and last 2.5x plus 5.5y plus 4.2z equal to 29.2. We can solve this system by using the Gaussian elimination method. We can use augmented matrices to help us solve system of equations because they simplify operations when the system are not encumbered by the variables. In Gaussian elimination, we transform the augmented matrix into row echelon form and perform the backward substitution to discover the values of unknowns. The augmented matrix of this system is First row 2.8, 4, 5, 27.5. Second row 3, 3, 4.7, 26. And the last row 2.5, 5.5, 4.2, 29.2. The right-hand side matrix is the fraction form of the left-hand side matrix. Next, we reduce the matrix to row echelon form. First, we multiply first row with 5 per 14 to get new first row, which is 1, 10 per 7, 25 per 14, and 275 per 28. Then, we multiply first row by negative 3 and add second row to get new second row, which is 0, negative 9 per 7, negative 23 per 35, and negative 97 per 28. Next, we multiply first row by negative 5 per 2 and add third row to get new third row. We multiply second row with negative 7 per 9. The new second row will be 0, 1, 23 per 45, 97 per 36. The next step is we multiply second row by negative 10 per 7 and add first row. We multiply second row by negative 27 per 14 and add third row. The new third row will be 0, 0, negative 5 per 4 and negative 11 per 20. Next, we multiply third row by negative 4 per 5. The new third row will be 0, 0, 1, 11 per 25. The next step is we multiply third row by negative 90 per 80 and add first row to get new first row. And the last step is we multiply third row by negative 23 per 45 and add second row. After reducing the matrix, we transform the solutions from fraction form to 4 decimal places. So, x equal to 5.5078, y equal to 2.4696, and z equal to 0.4400. Thus, the volume of the solution containing A is 5.5078 gram per cubic centimeter. For the solutions containing B and C, the volumes are 2.4696 gram per cubic centimeter and 0.44 gram per cubic centimeter respectively. That's all from my part. The next part will be presented by Heng. She will present problems 2. Thank you.
Good morning, Doctor and my friends. I'm Heng Keng with metric number 269659. Now I would like to talk about problem 2. Some of the students know what is the chemical reaction will be produced, but they don't know how to balance a chemical equation. So we can apply the theory of linear algebra to solve this problem. So our problem is balance the chemical equation W iron oxide plus X carbon to Y iron plus Z carbon dioxide. So we need to find out how much of each molecule is needed to satisfy the law of conservation of matter. The amount of each molecule needed is represented by W, X, Y, and Z. So first, unbalanced chemical equation is W iron oxide plus X carbon to Y iron plus Z carbon dioxide. So the amount of each type of atom is written in parentheses, which is 2W iron plus 3W oxygen plus X carbon equal to Y iron plus Z carbon plus 2Z oxygen. So my group member will continue to the solution of this problem. Thank you.
Good day, madam. My name is Chua Chen Yong and my matrix number is 271130. Now I will continue the part from KA. The second step is to compare coefficient of iron, oxygen, and carbon, which will get 2W equals to Y, 3W equals to 2Z, X equals to Z. Then we put this information into matrix form and perform Gauss-Jordan elimination. After that, the result is W minus 2 over 3Z equals to 0, X minus Z equals to 0, Y minus 4 over 3Z equals to 0. Since Z is a free variable, Z equals to T, W will equals to 2 over 3T, X equals to T, Y equals to 4 over 3T. Let's assume T equals to 3. We will get the value of W, X, Y, and Z, which are 2, 3, 4, and 3 respectively. Therefore, the balanced chemical equation should be 2 iron trioxide plus 3 carbon equals to 4 iron plus 3 carbon dioxide. That's all from me. I will pass to the next presenter, Yamini. Thank you.
conclusion, balancing chemical reaction is not chemistry, but it is just linear algebra. This study investigates that every chemical reaction is represented by non-homogeneous systems of linear equations only. This work presented a formal systematic approach for balancing chemical equations, and the Gauss-Jordan elimination method are used. The mathematical method presented in this project applicable to all cases in chemical reactions. The results indicated that there is no any contradiction between the various methods that were applied to balance the chemical reaction equation. Thank you.